In this video, I will explain how to minimize a given DFA. Suppose this is our given DFA whose state A is beginning state and D and E are final states. That means set of states A, B, C, D, E. D, E are final states, A, B, C are non-final states. Here the transition table is A, B, C, D, E for one input. For A input, the next states are D, E, C, D, E, and for B input, the next states are B, C, C, D, E. Now, how to find out the minimized DFA? First, you draw the transition table. After drawing the transition table, you see what are the set of states. So these are the set of states. You divide these set of states into two subsets. One subset contains non-final states and another set contains final states, and mark it zero equivalence. So zero equivalence, that is A, B, C. These are set of non-final states and final states D and E. So this is zero equivalence. If you want to find one equivalence, you see, you apply all the inputs for two subsets of the states and find out the next states. Now you consider A and B. So A and B for zero input. A, B for zero input, what will happen? A and B for for A input, because here input symbols are A and B. A and B for input A, the next states will be D and E. D and E. So these are in the same set. Since these are in the same set, so A and B are one equivalent. Again, you check for B. So A for input B, what will happen? A, B for input B, the next states will be B, C. B, C. Next states will be B and C. So this is B, this is C. B and C are one equivalent. B and C are in the same set. That's why for A input, the next states D, E are in the same set, and for B input, the next states are also in the same set. That's why A and B are one equivalent. So we write here A comma. So what will happen for C? If we check A and C are one equivalent, then also A, B, C are one equivalent. Or if you check B and C are one equivalent, then A, B, C are one equivalent. So first we check uh, either AC or BC. So we check A and C. A, C. What will happen for A input? A and C for what? A input, D and C. D and C. So C is available here, D is available here. That's why A and C are not one equivalent. That's why we write C is a single state. Then we have to check for D and E. D and E for A input, they will go to D and E. That means next states are D, E, and these are available in the same set. For B input, D, these are available in the same state. That's why D are one equivalent. Again, by seeing the one equivalence, you find out two equivalents. How to find out two equivalents? You check A, B whether these are two equivalents or not. So you see A, B for A input. The next states are D and E. D and E, these are available in the D and E for AB for A input. The next states are D and E. Since D and E, so D and E in the same set. That's why A and B are one equivalent. Again, we check for B, A A for one, B input it will go to B. B for one B for B input it will go to C. BC. So BC, but B here, C is here. These are in two different set. That's why A and B are not two equivalent. Why? Because if you consider A and B, for A input we will find next at D which are in the same set. But for B input, these are not, the next states are not in the same set. That's why A and B are not two equivalent. So we write and B are two different. Then since C is single state, so we write like this. Then D for these are two equivalents or not. D means you see D on A input, the next states are D which are available in the same set. For one B input, they are available in the same set D. So that's why D are two equivalent. Now find out three equivalents. So for three equivalents, since it is single set, so we write A. For single set B, we write like this. C like write like this. For D, DE. For A input, they will go to D. Same set. D for B input, same set. So we write D and E. So now you see two equivalents and three equivalents are same. So we stop the equivalence partition. So after stopping the equivalence partition, we consider each subset as a state. So this is a state, this is another state, this is another state, and this is another state. That means our minimized DFA contains only four states. What are those? First A, since it is the beginning state of given DFA, so it is beginning state. This is B, and this is C, this is D and E. Four subset means four. So now you see the input. This is A state. For A input, it will go to D. For A input, it will go to D. For B input, it will go to B. Two transition over. For B, it will go to E. For B, for A input, it will go to E. For B input, it will go to C. That means this is. Then we consider C. Two transition over C. C for A input it will go to C. For B input it will go to C. So C for A input it will go to C and B input it will go to C. Then D. D for 0 input it will go to D. Sorry, for A input it will go to D and for B it will go to D. For E, A input it will go to, since E here, so E for A input it will go to E and for B input it will go to. Now A is the beginning state, since D is the final state of the given DFA. So here minimized DFA also, in minimized DFA D is the final state. So this is the minimized DFA which contains only four states. Thank you.